Welcome to Precalculus Concept 23D, angles and radian measure, and we want to establish the relationship between radians and degrees. I got 5 boxes for you, but they go kind of fast. So let's just go ahead and dive in and I'm going to give you the answer. Okay, why is it true that there are 360 degrees is equal to 2 pi radians? Why is this true? This is the answer, and this is the basis for how we do things and convert from radians to degrees, but let's figure out why it is. Okay, let's consider a circle for just a moment. If I travel all the way around the circle, then everybody would agree that I've traveled a full 360-degree rotation around that circle. Okay? Now, you may remember from geometry class that the circumference of any circle is equal to 2 pi r. So that means that the total distance all the way around the circle is equal to 2 pi r. So you may already be making some kind of connections. Now in the previous video we established that the definition of a radian is equal to the arc length divided by the radius of the circle. Well, the arc length s, if I go all the way around, isn't that just the circumference? Of course it is. So now I can substitute the circumference for 2 pi r, and then of course I still have a division by r. And look, the r's cancel, and I'm left with 2 pi. So the definition of a radian then, if I travel 360 degrees, I must be going 2 pi radians all the way around. So in the very first box, I told you in the very first lesson that there were just over 6 radians in a full circle. That's true, there's 6.28, because that's double what pi is. Now, if you take this a little bit further, check this out. If I divide both sides by 2, ladies and gentlemen, it's now true that 180 degrees is worth pi radians. Oh my gosh, look at that. 180 degrees is exactly worth pi radians. So that means if I drew a straight line of 180 degrees, I've got a distance of pi radians. Okay, or an angle measure of pi radians, I should say. Then, to go even further, let's say that I want to know what 1 radian is worth. So if I divide both sides by pi, I can see that 1 radian is worth 180 degrees over pi, which is approximately 57.3 degrees. So remember in the beginning, the circle, I said that, or the definition of a radian, if this is r and this is r, and then you bend it back, that angle that we create right there, you guys, ladies and gentlemen, that is 57.3, or more classically interpreted as 180 over pi. Okay, so here's the big reveal, all right, and I have it down for you over here, and this is the little chart that I want you guys to copy in your notes, and let me make it bigger for you. Oh, sugar snap, I made it wrong. Can I do it all? Oh, shoot, hold on. Okay, sorry about that. I fixed the problem, and here we go. Here's the big reveal. I want you to put this in your notes. Ah, okay, there it is. Okay, here we go. To convert a degree into a radian, we're going to multiply by this key factor of pi over 180. If we're going to take a radian and take it and turn it into a degree, we're going to multiply by this key factor of 180 over pi. So take a moment and copy this down. So degrees, to turn a degree into a radian, we multiply by pi over 180. To take a radian and turn it into a degree, we multiply by 180 over pi. And all that comes from this algebra on the left-hand side. Okay, box 2, let's do some examples together to really take this idea home. If I want to convert a degree to a radian, okay, so I want to take 30 degrees and I want to turn it into a radian. So I'm going to multiply by my factor of pi over 180. So that's going to give me 30 times pi divided by 180. And all I'm going to do is simplify, you guys. So 30 or 3 over 18 becomes pi over 6 radians. Okay, so 30 degrees is the equivalent statement of pi over 6 radians. Let's take 90 degrees. I would take multiply by my conversion factor of pi over 180, and I would get 90 pi over 180, and of course 90 over 180 is a half, so therefore 90 degrees is now the equivalent statement of pi over 2 radians. Let's take a negative 135 degrees. I'm going to take a degree, I'm going to multiply it by my conversion factor of pi over 180, and that's going to give me negative 135 pi over 180. I'm going to just simplify my fraction, and I would end up with negative 3 pi over 4 radians. Okay, so the equivalent of negative 135 is negative 3 pi over 4 radians. So the important factor here, ladies and gentlemen, is understanding the multiplying factor of pi over 180 to take a degree and make it a radian. Okay, you guys try real quick. Convert 60 degrees to radians. I hope you got the right answer of pi over 3 radians. Woohoo! Alright, let's go the other way. Let's take a radian and make it a degree. Okay, so if I have a radian, I have pi over 4 radians. I'm going to multiply by 180 over pi. Notice it's the reciprocal of the ones in the last box. Notice the pi's cancel. I get 180 divided by 4. So therefore, I'm getting 45 degrees. So pi over 4 is equal to 45 degrees. Let's take negative 5 pi over 3. I want to change it from a radian to a degree. So I'm going to multiply my conversion factor of 180 over pi. And the pi's are going to cancel out. So I'm going to get negative 5 times 180, all divided by 3. This is going to give me negative 300 degrees. So negative 5 pi over 3 radians is negative 300 degrees. Okay, let's take 3.2. This is a radian measure. Notice it doesn't have a pi in it, but that doesn't matter. It doesn't have to. So take 180 divided by pi. So this is going to be 3.2 multiplied by 180 and then divided by pi. So this is approximately 183.4 degrees. Okay, so there we go. We can convert a radian to a degree by multiplying by 180 over pi. Okay, finally you try it. Take 4 pi over 3 and make it into a degree. Hopefully you got the right answer of 240 degrees.